Okay, tell me what is the problem with this question here? Okay, apart from it being difficult. Yes. You must understand which is a variable, which are the two variables you're looking at, right? So the diagram shows a solid spherical ball of 6 radius. So this is fixed. The radius shape is fixed here. This is the radius sphere. Then the rest inside of the cone is height h, and then the radius is r. So essentially, which are your two variables? Two variables are, right? R and h, right? Imagine if you can vary the r and the h, the two unknowns, which is like that. So if you say you have the h is larger, then the r will be smaller. Do you agree? The r will be here. So essentially, if the h is shorter, obviously the r will be longer lah. You draw the cone out. You know what I'm saying? Okay, so you some shape or form where r and h are related. Okay, so show that the volume V of the cone is given by this over here. So how? Okay, the volume V of the cone is actually 1/3 r square h. Agree? 1/3 base area times height. So 1/3 base area times height, if you can do that. So then now the question is, this volume here and this volume here, what's the difference? What's the difference here? These two. This is in terms of R and H. This one has only in H, right? So in other words, you just like what we usually do in application differentiation, which is you need to be able to find the relationship between both of them. Now this shape here is very common kind of question asked in exam. So what you need to understand is actually you need to form you look carefully, you need to look for the similar triangle. Okay, the similar triangle is here. So if you look at okay, let's look at this one. This is alpha. Okay, this is alpha. So you label everything out lah. This is alpha. Then let's say this is 6. These are all 6, right? This one is 6 also. Radius. So you ask yourself, what is this length here? This length here is h minus 6. H minus 6. So this is h minus 6. Okay, great. Now, what's the next thing is you need to find a similar triangle. Can you tell me which is a similar triangle? The similar triangle is actually inverted. So this one here, this is one triangle here. And the other similar triangle would be the outer layer one, which is this one here. You see the two similar triangle there? So the small one, okay, or maybe I just put this as a PQR here, PQR. Then maybe I just put PQR. Okay, and decode PQR and PXY. Okay. Now take note of this. It's actually inverted. So you look at this small triangle here, which is the hypotenuse. PR is hypotenuse, right? So this is a hypotenuse. The 6 is what? The opposite, right? So this is where it becomes confusing because a lot of students, you look at the big one, right? This H here is it a hypotenuse? The big one, PXY. What is it? It's actually the adjacent to the angle there. Then the opposite here is what? This is opposite, right? You see that the similar triangle values, they are actually reversed. Okay, so you just have to be very careful. So I'm gonna just draw two small triangles so that we can relate. So you can see that one is being flipped. So the big one, I'll just keep it as it is. So the similar triangle here. So this is alpha. This is P, this is Q, and this is R. This is 6, and then this is H. The H minus 6 is here. Then this is 90. This is 90. Then this is P, Y, X. Then that will be HCM here. R here. I'll leave it like that first. So this one is alpha. This is also alpha, right? So by virtue of the property of similar triangle, you know that these two corresponding side, you need to find this over here. Lah. So I think the hypo is easier to find. So I'm going to write this as, it really depends which one do you want to find. It depends which one do you want to do. Lah. So do you want to find px or you want to find qp? Either one is fine. Px, okay, px is easier. Okay, square root h square. Okay, correct. So this is done. So hence by properties of similar triangle, we know that 6 over r is equals to h minus 6 over square root h square plus r square. No problem. What's the point of making this expression here? Can someone tell me? What's the point? Basically, you want to relate h and r. That's the whole idea there, because if you can't find h and r, then you cannot change what the volume into this because this is only in h You know what I'm saying? This is in h and r. So the linkage between these two is actually an equation there. So what we do is, this case here, we need r square, right? So can I square both sides? I'm too lazy to cross multiply first. So 6 is 36 r square. H minus 6 square. H square plus r square. Then what I'm going to do is I'm going to just cross multiply. So 36 h square plus r square equals to r square h minus 6 square. Make r square the subject. Make r square the subject. So don't just expand first. So don't just see this one, then you expand, okay? You need to make r square the subject. So I'm going to just slowly make this. There you go. For this case here, so this one here, r square h minus 6 square minus 36. Okay, so what should this be? It should be your, this is 6 square, right? Any issue that this is 6 square? So initially, so you must be able to see that this is a square minus b square, much easier lah. Then you don't need to expand. Okay, this is a square minus b square. So in other words, if you make r square the subject, it'll be 36 at h square. H minus 6 minus 6, then h minus 6 plus 6. Okay, so that's the rule of the game. You have got this is your can people. This is done. Life is good. Then we're gonna take on a new perspective on life, which is to make math our favorite subject. So we cancel off this one and this one. We just sub. So essentially, sub r square equals to 36h over h minus 12 into 1/3 pi r square h. Great. We got this, so v is equals to 1/3 pi . Okay, that will be v. Now the good thing about showing kind of question is, you know whether your answer is correct. Okay, and at the same time, you also know whether your answer is wrong. It's a double-edged sword. You know you're screwed when you see it. So moment of truth. Wow, heng bo, Mr. Gun, you got it correct. Let's try. Okay. Yeah, sometimes I careless mistake or I explain. So that's that. Part 2 should be quite okay. Give the H can vary. Find the value which V is stationary. So part 2. dVdH. Okay. Now V, okay, this is what I'll do. The V is a constant. So usually I'll just exclude it out. The 12 pi is a constant. So H square, H minus 12. Okay, don't get the 12 pi in because it's very annoying. So this case here, use quotient rule. H minus 12 square. V du dx minus U dV dx. Job. That's it. Du dx. So done. I'm gonna factorize out the H. Now I want you to be aware that usually I like to factorize things out. Okay, because I explained it before. I'm not gonna say it again. Factorization is more superior than expanded form. Okay, factorized form is usually more superior because we can see what. So when you see can factorize, just factorize it out. So just understand that you factorize things out because it'll be much easier, right? Don't expand. I know students like to expand. I don't blame you all for that because it's a very lazy way of thinking. Okay. So this is this. Then after that, I'll just get a stationary value. I know dVdH is just equals to 0. Okay, reject. That's the, so H equals to, hence H equals to 24 cm. Either way, whether max or min, I will suggest using first derivative test. So you just do part 3 because it's so complicated, right? This expression here. So I'm just going to use first derivative test. This case here, H 24 plus and 24 minus dVdH. This is 0. This is complicated, so I'm just going to use dVdH, first derivative test. It's a value of the derivative. So what you do is you key this. Remember how we key in, right? 12 pi. Right, so H, I let it be alpha lah. Then alpha x minus 20. Remember how to do this because I don't even think your school teacher may not even know how to use this function where you can substitute a inside. Okay, not all teachers will know how to do it lah. But you know that by substituting a equals to 24, so a 24, press storage, then you press a, you store the value. This has to be 0 lah. So then after that, you just put 24 plus a very small value, let's say 0.001. Then you store it as x a again. So now this is your new a. Key in, this is positive. So this is a positive value. Just need to be positive. Then hopefully the other side is negative. So we're going to hit 24 minus 0.0001. Store it as a. Go up. Enter negative. So that will be negative here. Okay. So the shape will be negative 0. Yeah, the value is negative. So hence by first derivative test. Okay. B is a minimum point. What did they ask? They say, yeah, it's a stationary value. So stationary value will be hence minimum value of V. They want you to find the value lah. So 12 pi. I'm just going to put it in exact form.